Today we're exploring how to select the right solar panels for powering a single-phase 220-volt 1.1 kilowatt motor. Series connection is necessary when the voltage needed exceeds the VMP voltage provided by a single solar panel. By incorporating each added solar panel in series, you add the VMP voltages together to find the new total VMP voltage. This process can be repeated as necessary to achieve the desired voltage for your controller. Remember, when connecting in series, always check the maximum voltage rating. Exceeding this limit can damage your panels. Parallel connection is necessary when the current or amperage needed surpasses the IMP current provided by a single solar panel. By connecting each added solar panel in parallel, you sum up the IMP amperages to calculate the new total IMP amperage. This approach can be repeated as needed to reach the required current or amperage for your motor. Remember, when connecting in parallel, always check the maximum current rating. Exceeding this limit can damage the panels. Series parallel connection is ideal when both the voltage and current required exceed the VMP and IMP values provided by a single solar panel. By adding solar panels in series, you aggregate the VMP voltages for the new total VMP voltage, and simultaneously, by adding panels in parallel, you accumulate the IMP amperages for the new total IMP amperage. Note: when connecting two rows of panels in parallel, both rows must have the same amount of panels. Total wattage. The total wattage in various connection configurations stays consistent. Regardless of the chosen connection scheme, you sum up the total number of solar panels in your system and then multiply it by the wattage of each individual solar panel to find the overall system wattage. For instance, if you have 10 solar panels with a rating of 550 watts each, the calculation will result in a total system wattage of 5,500 watts or 5.5 kilowatts. Series connection example 1. Say we want to power a single-phase 220-volt 1.1 kilowatt motor. We need to find the number of 550 watt panels, as shown in the solar panel specification example, needed based on specific voltage and current parameters. The selected panel provides 40.9 VMP, 13.45 IMP, and a VOC of 49.62. Since the current needed by the pump is lower than what one panel offers, no parallel connection is necessary. However, the required voltage is lower than the panel's VMP, showing the need for a series connection. To calculate the number of panels needed, we divide the required VMP by the available VMP. Always refer to your inverter manufacturer specification for the required VMP voltage. This series connection ensures we meet the voltage requirements without exceeding the system's maximum VOC, keeping everything safe and efficient. And there you have it, 8 panels in series providing the perfect power solution for our motor. Series parallel connection example 2. Our selected panel has a 72.68 VMP and 4.55 IMP. To achieve our goals, we'll need to creatively combine these panels. Say we want to power a single-phase 220-volt 1.1 kilowatt motor again. Now, let's do our calculation. The selected panels provide 72.68 VMP, 4.55 IMP, and a VOC of 90.85. Since the IMP needed 8 amps is higher than what the panel offers, 4.45, we need a parallel connection. Now we know that a series and parallel connection is required. Series parallel. To calculate the number of panels needed in series, we divide the required VMP by the available VMP. 310 divided by 72.68 equals 4.26. Rounding up, we need 5 panels to meet the VMP requirements. To calculate the number of rows needed in parallel, we divide the required IMP by the available IMP. 8 divided by 4.55 equals 1.76. Rounding up, we need 2 rows in parallel to meet the IMP requirement. Now we can see that there will be 2 strings of 5 panels in series. meaning 5 panels in series connected in parallel with another 5 panels in series. This all adds up to 10 panels in total. However, to ensure the total VOC does not exceed the maximum limit, 5 times 90.85 equals 454.25 VOC. This exceeds the maximum VOC of the inverter. This indicates that this panel will not be suitable. You would need to choose another panel with a lower VOC voltage. What solar challenge will you solve next? Stay tuned for more insight into the power of the sun. Embrace the future of energy. Explore, learn, and innovate with us.